welcome all for today's class. So today we will see about the polynuclear aromatic hydrocarbon, the part 4 of this topic. So we have already seen what is polyaromatic hydrocarbon and their structures. We have seen about naphthalene, anthracene, phenanthracene, how to prepare, right? What are the reactions? And today we will dig deeper into this topic and we will see about the reactions of naphthalenes, especially the electrophilic substitution reaction of naphthalene. So, under the electrophilic substitution reaction, electrophilic substitution reaction meaning is electrophile is on positive species, and naphthalene is having like benzene, it is having electrons, right? Because you can see here there is our double bonds. There are 5 double bonds are there, meaning each double bond is made of 2 electrons, right? There are 10 pi electrons up there. These are pi bonds. So this is electron rich. You can say this is an electron rich compound, and it can react with electrophile. Electrophiles are positive species. So electron rich species like to attack the positive species, right? Positive, because positive species want electrons, and more electron also want the positive charge to make it more stable compound. So this halogenation, this electrophilic substitution reaction works very nicely in the case of naphthalene. So this is an halogenation reaction, meaning the chlorine, bromine, nitrogen and fluorine. So halogenation reactions of naphthalene we will see as an example of the chlorination of naphthalene. You can see as an example of this halogenation reaction. So naphthalene reacts with chlorine in the presence of iron chloride. So this is the iron chloride is the catalyst used for this reaction. So we have already seen in benzene chapter that benzene react with some electrophile in the presence of Lewis acid, right? So this is a Lewis acid in this case, iron chloride, this chloride Cl2, chlorine reacts with naphthalene and gives the product is 1-chloro-naphthalene. This is the first position. We have already seen numbering scheme. This is the first position of naphthalene. So it is we get the 1-chloro-naphthalene as the product. Similarly, if we take bromine, so instead of chlorine we take bromine, what you will get is 1-bromonaphthalene, right? So what is electrophile in this case? So we can have the discussion about what is an electrophile producing in this reaction. For example, in the case of chlorine we will see only one chlorine, right? What is the byproduct? The byproduct will be HCl, right? Because there is a hydrogen here. There is every carbon is having one hydrogen except these two are fused here. So it is 4 bond already satisfied. So there are 8 hydrogen, 1, 2, 3, 4, 5, 6, 7, 8 hydrogen, and here it is only 7 hydrogen, because one of the hydrogen here is gone. One of the hydrogen is gone from here and one of the chlorine is gone as a HCl. The byproduct is HCl. So what is the electrophile in this case is Cl plus, right? Cl plus is the electrophile, because one chlorine is gone as an HCl, so electrophile is Cl plus. Similarly, here also same thing. The Br plus is an electrophile. This is electrophilic substitution reaction. Br plus attack here. One Br is left, right? That will go as an HBr in this case. And here you can see here the Lewis acid here is used this iron bromide. So we changed iron chloride to iron bromide because otherwise you have mixed byproduct, right? HCl, HBr, like that, because there is one Br here, and if we have HCl here, iron chloride here, you will get HBr as a byproduct and also HCl also as a byproduct, because there to make it even, to make it same, if you take a bromine as a reactant, you also use this iron bromide as the Lewis acid. Same you can find here. If you use chloride, you can use the iron chloride as the Lewis acid. So naphthalene reacts with bromine to give the 1-bromo-naphthalene as the product. So this is an halogenation. So same thing will happen in iodination also. Iodination reaction, if you take naphthalene and add iodine, you will get iodo-naphthalene as a product, right? 1-iodo-naphthalene. With this, we will move on to see the next electrophilic substitution reaction of naphthalene, that is acylation reaction. Acylation reactions of naphthalene, which is a very famous reaction called as Friedel-Kopf acylation. The Friedel-Kopf acylation and Friedel-Kopf alkylation is very two important reaction of carbon-carbon bond formation reaction. So this is a carbon-carbon bond formation reaction. So, this reaction can be possible with naphthalene, because this also generate an electrophile. We have seen in the benzene chapter that electrophile generated in the acylation reaction is called acyl cation, right? Acyl cation is the electrophile. So, CH3CO plus, CH3CO plus is an electrophile, right? So, how the reaction happens? This is a general scheme of reaction. Naphthalene react with acyl chloride. In this case, it is called an acetyl chloride. You can change the CH2, you can change to CH3, CH2, ethyl, right? This is methyl, so it is called acetyl chloride, CH3COCl plus AlCl3 as the Lewis acid. The Lewis acid in the case is AlCl3. So, what product you will get is one acetyl naphthalene. So, CH3 attach here, right? This from here, CH3 attach here, and what is the byproduct? Same thing, HCl. Right? This chloride is gone as an HCl. This chloride and this one hydrogen here has gone as an HCl. So, plus HCl. So, this is called as Friedel-Kopf acylation reaction, and we can also use for other compound like benzene also. We have seen previously benzene, naphthalene, anthracene. We can use any reaction, any compound having electron rich reactant. So, this is, we have know that this is an electron rich reactant, react with the electrophile. Electrophile in the case is CH3CO plus. So, CH3CO plus attach here and give the one acetyl naphthalene as a product. So, naphthalene react with acetyl chloride in the presence of Lewis acid catalyst, that is AlCl3, to give one acetyl naphthalene as a product. This is a Friedel-Kopf acylation reaction. So, I have mentioned previously that Friedel-Kopf acylation and alkylation are very important reaction, and this is the second reaction, that is an Friedel-Kopf alkylation reaction. So, comes under alkylation reaction of naphthalene. Okay. This is also electrophilic substitution reaction, because electrophile is produced, that a positive species is produced. What is positive species in this alkylation reaction? This alkylation reaction, this example I have given here, it is methyl chloride reaction, right? Methyl chloride plus benzene plus naphthalene. So, automatically the electrophile will be CH3 plus. CH3 plus will be the electrophile. And this you can see here that AlCl3 is the reactant, the Lewis acid, and what you will get is one methyl naphthalene. So, I have told previously that this is the carbon-carbon bond formation reaction, and you can see a new carbon bond is formed here. So, C and then with this C carbon of the naphthalene. So, these are the carbon-carbon, new carbon-carbon bond formed, one methyl naphthalene. So, what is the general reaction is naphthalene plus methyl chloride give the one methyl naphthalene as a product. So, next we will, so far we have seen, so same thing here, I forgot to mention that here also carbon-carbon bond is formed, right? Friedel-Kopf's reactions, acylation and alkylation is our carbon-carbon bond formation reaction. So, we can see here that in the case of the acylation reaction, a new carbon-carbon bond is formed here between the acyl group, CH3CO group, and this carbon. So, this is a new carbon-carbon bond. So, with this we will see now what discuss about some oxidation reactions of naphthalene. So, first what we will see what is oxidation. This review, oxidation is addition of oxygen, we know that. Reduction is addition of hydrogen. That is another way to represent oxidation is a loss of electron and reduction is gain of electron. So, in the case of organic reaction, we can easily follow the reaction is oxidation reaction or reduction reaction by looking at the products and the reactant. So, if you see what is the reactant here, the reactant is naphthalene, okay. And what naphthalene is converted to? Naphthalene is converted to some product. But you can see here in that product, new product, this is a new product. In the new product, there is oxygen present here. In the case of naphthalene, no oxygen. In the case of this new product, new oxygens or atoms are formed. Or oxygen, carbon, oxygen, new bond is formed. This is carbon, this is oxygen. This is carbon, this is oxygen. So, two new oxygen atoms are incorporated in the product, right, in the final product. So, you can see here this is a reactant, no oxygen is there, you can see the product, there is oxygen, we can say this is easily we can say this is an oxidation reaction, because addition of oxygen in the product. So, what we will see a oxidation reaction example, that is naphthalene, so naphthalene undergo oxidation reaction easily, because naphthalene is an electron rich compound. It can easily lose electron, or it can, in other words, it can lose electron and gain oxygen, right? It attach oxygen with chromium trioxide. Chromium trioxide is a very strong oxidizing agent, means it can supply oxygen, it can oxidize, it can take electrons from the substrate. So, chromium trioxide react with naphthalene in the presence of acetic acid. This is a acetic acid as an act as a catalyst. Okay, it supplies them H plus, right? Acetic acid can easily supply H plus. It give 1,4-naphthoquinone as a product. This is a product. So, in the naphthoquinone, you can see the one double bond is reduced here, is gone. This is one single bond here. There was one double bond, only one. Here it is having two double bonds, and two oxygen atoms are incorporated. So, this is a naphthoquinone, quinone meaning quinone having a benzene ring with two oxygen, double bond O, right. This is a naphthoquinone because it is attached with another benzene ring. So, it is naphthoquinone, naphthalene ring with two oxygen. So, naphthoquinone. What is, why it is called 1,4? This is a 1, right. This number is 1, and this 2, 3, and this is 4. So, 1,4 naphthoquinone. If the oxygen is here, then you can say 1,2-naphthoquinone like that. So, this is a important oxidation reactions of naphthalene. We can prepare naphthoquinone as a product. So, if we add more stronger oxidant, I told that chromium trioxide itself is a good oxidant, strong oxidant. We get this product. What happens if we add very strong oxidant like KMnO4, and in the presence of H plus, any acid, right? Any acid we can use. Just main point is it should supply some proton. Here we use acetic acid, it can also supply proton, right? This H plus, and here some any acid. So, acetic acid we can use, HCl we can use, whatever acid which supply proton. So, any acid, what we can see here, it is one aromatic ring is completely gone, right? Is completely gone, eliminated. That means there is a breakage of this double bond, and this oxygen got incorporated here. So, this whole part, this carbon-carbon, this bond is completely gone, right, and we get this phthalic acid. This is a product. Phthalic acid, the oxygen is incorporated here, COOH. So, 4 oxygen are incorporated, right. There are 4 oxygen in KMnO4 and 2 here incorporated here, and this is called as phthalic acid. And this phthalic acid is used as a starting material for making many different drug material, chemicals and all. So, this is one of the very important reaction. From naphthalene you can get phthalic acid, because this is phthalic acid is having many good number of application in chemistry and pharmaceutical field. So, naphthalene undergo oxidation reaction with potassium permanganate KMnO4, which is a very strong oxidant in the presence of any acid, to give phthalic acid as the product. So, these two important oxidation reaction you can remember. One is the preparation of 1,4 naphthoquinone, and one other one is preparation of phthalic acid, both by oxidation reaction. Now, we will see important reduction reactions of naphthalene. So, reduction I have already told is an addition of hydrogen, right? It's an addition is hydrogen is added into the naphthalene. So, you can see here naphthalene undergo reduction reaction with sodium. So, reduction reaction meaning we are supply electrons. Sodium can supply electrons, right? It can sodium is having one electron in the outermost shell, which you can easily donate, right, to make it a stable configuration. So, sodium, what will happen is, in the presence of ethanol, any alcohol solvent, we have used here ethanol to give 1,4 dihydronaphthalene. So, this hydrogen got added here, this 1 and this 2 here, 1,4 dihydronaphthalene as a product, right. So, what is happening here is one of the double bond is reduced here. So, that means one double bond is gone, and this hydrogen got added here, and this double bond shift here. So, one hydrogen added here, one hydrogen got added here. This is the 2 hydrogen got added here. So, you can see here what is the molecular formula of this compound. This is 8 hydrogens are here, just calculate only hydrogen because carbon remains same in both structure. Carbon is 1, 2, 3, 4, 5, 6, 10 carbon, right? Here also 10 carbon. Only we have to check what is how many hydrogen here and how many hydrogen here to calculate how many hydrogen got added into the product. So how many hydrogens are here? 8 hydrogen. You know already 1, 2 hydrogens are here, 3, 4, 5, 6, 7, 8. What about here? 1, 2, 3, 4 hydrogen here. Okay. 5, 6. There are 2 hydrogens are here. 5, 6, 7, 8, 9, 10. So there are 10 hydrogens and here 8 hydrogen. 2 hydrogen got added in the product to form the 1,4 dihydronaphthalene. So 2 hydrogen, di means 2. 2 hydrogen got added into the product from the naphthalene in the presence of sodium. So that is a reduction reactions of naphthalene. So what will add, same thing will try, what we will add more stronger reducing agent. We have seen previously how to, what happens if we add strong oxidizing agent, we will see what happens if we add a more stronger reducing agent. So if we add a very strong reducing agent like this sodium in the presence of isoamyl alcohol, so we have changed this solvent, right? We did not change the reducing agent, same thing, sodium, but we changed the isoamyl alcohol as that solvent we have changed. This also has an effect because it forms a tetraline. Tetraline meaning this all the double bond got removed and hydrogen got added here. The double bond is removed, hydrogen got added. So how many hydrogen got added? That you can calculate again, same thing. There are 8 hydrogen we have seen, and we can calculate how many hydrogen here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 4 hydrogen got added here. Tetraline, okay, tetra means 4, 4 hydrogen got added here. Okay, so this is how, if you have a reducing agent with change the solvent or increase the efficiency of the reducing agent, you can get different products, different vital important products. And here you can get prepare naphthalene, from naphthalene you can get tetraline, which is also having a good number of application in chemistry and pharmaceutical chemistry. What happens if you had a very strong reducing agent or catalyst? Here we can use naphthalene plus hydrogen. Hydrogen is a gas, right? And in presence of nickel catalyst. We use this is a very strong reducing catalyst. It can supply hydrogen. It can add hydrogen into the substrate. This is a substrate. Add hydrogen into the substrate, and in the presence of nickel catalyst, which is a strong catalyst for reduction purpose, you can get decalane. Means all the 5 double bond got reduced. Okay, all these are reduced, and you will get tetraline. This is no double bond here. This is acyclic structure. Okay, no double bond here. So how many hydrogens got added here? You can calculate here. This is 8 hydrogen here. Okay, and here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 hydrogen here, and here only 8 hydrogen. So 8 hydrogen got added here. 1, 2, 3, 4, 5, 6, 7, 8. 8 is 16, right? So double the amount of hydrogen are added here, and this is called a decalane. So with the help of catalyst and strong reducing agent, we can selectively prepare whatever we want from the naphthalene. If we want decalane, we can use this catalyst. If we want tetraline, we can use this previous catalyst, this sodium and isoamyl. This combination we can use. And in the case of we want to prepare this 1,4 dihydronaphthalene, we can use this sodium and ethanol. Ethanol as that combination reactant. And if you use a strong catalyst here, you can get a completely hydrogen got added here into the product. Completely, you can say completely reduced. The substrate is completely reduced to decalane. You can say like that. So so far we have seen what is electrophilic reactions of naphthalene. Okay, under this we have different types like halogenation reaction, acylation, alkylation, sulfonation also we can use. We have seen previously in the case of benzene we have sulfonation, and we have also seen in the case of naphthalene also, that is also electrophilic substitution reaction, and we have also seen the oxidation and reduction reactions of naphthalene. So and now with this we will see about some uses of naphthalene. Okay, so we have seen all the reactions of naphthalene, let us move on to see the naphthalene uses. So, very important use for naphthalenes are it used as a moth repellent. Okay, this can drive away for like cockroach. So, we can keep it in the closet to drive away all the moths. So, this is a naphthalene balls, it can available commercially anywhere in the shops. We can get this naphthalene ball, and if we keep it in the closet, we can it can repel it, all the moths. So, it uses as a moth repellent, and it also used for preparing beta-naphthol. So, we will see more detail in the next class about this beta-naphthals, but beta-naphthals are dyes. They are tanning agent which can use for tanning any clothes or any this is a dye. So, we can use in any number of applications. This is the structure, and this is the material, the texture of this beta-naphthol. You can see this texture, and you can make it this gray color and different colors by different substitution. And this is the basic structure of beta-naphthol. It is having a naphthalene ring with hydroxy group, OH group attached in the second position, right? This is the first position, and this is second position. The first position is called alpha position, and the second position is called the beta position. So, this is in the second position, or called as beta position, or called as beta-naphthals. So, these are the two very important uses of naphthalene. Apart from other use, we have seen that it can use to prepare different number of product, right, like naphthalene, naphthaquinone, decalene, tetraline, which is used further for preparing other drugs and other pharmaceutical chemical reagent. Apart from those uses, this is other two important uses of naphthalenes, like moth repellent and beta-naphthals. So this is for this so far for this class, and I will see you in the next class and talk about more about the this important polyaromatic hydrocarbons. Thank you.